All right, next question concerns heat. It's a question on the topic of heat. So let's revise heat. What do we already know about heat? We know that heat is a form of energy that makes things hot. All right. So far we've learned two forms of energy. We've learned about heat energy and we've learned about light energy. If you can remember just now, light is a form of energy that allows us to see. Heat is a form of energy that makes things hot. I repeat, light is a form of energy that allows us to see, whereas heat is a form of energy that makes things hot. Now, things that are just like light, things that give out heat are known as sources of heat. Things that give out light are known as sources of light, right? Just like light, the sun is our main source of heat. Just like the sun is our main source of light. Okay, so these are the things that we already know about heat. Please remember them because these are very important basic facts that you always need to know. Next, we also know that there is that temperature is a measurement of how hot or cold something is. But remember that we also learned that heat and temperature they are not the same. We'll spend some time here explaining just to as a form of revision. You can see that, for example, there are two containers here, two cups. All right, both of them are containing water at 60 degrees Celsius. Now, if right now we have both of these containers having the same temperature, and because the amount of liquid is the same, or the amount of water is the same, then they have the same amount of heat. What happens if we have if let's say we have um, this setup now, right? We have two similar containers, both filled with water at 60 degrees Celsius. Which one would have more temperature? The answer is both of them would have the same temperature. Okay, but if they ask you which container would have more heat energy, then the answer would be the one on the left, right? Because uh, even though the temperature is the same, but because there's more hot water here, there'll be more heat energy here. If you can remember it, in P4, you must have done an experiment where we put an egg, one with a lot of water and the other one with half that amount. If you did the experiment, if you were in my class, you would have done the experiment, you would see that egg inside the container with more hot water will cook even more than the egg inside the same temperature of water but much lesser water in the container. And this is because we wanted to prove that more water would have more heat energy. Another way for you to imagine this is to remember if you have two containers and you wanted to boil or you wanted to heat up these two containers, the one on the left will take a longer time than the one on the right because the one on the left would need much more heat energy for the water to absorb more heat energy compared to the one on the right. And uh, that is the reason why when there's more water here, it normally means there's more heat energy compared to the one on the right. Alright, okay, so we know that heat and temperature is not the same. What else do we know? We know that about heat flow. We know that heat flow flows from a hotter place to a colder place, or from a hotter object to a colder object. Some of you told me that heat always flows from an area of hotter temperature to an area of colder temperature. All that, using different words, but they actually mean the same. That heat flows from where there's more heat energy to areas where there are lesser heat energy. And it continues to flow between these two places or these two areas or these two objects or these two regions until both reach the same temperature. All right. So when matter becomes gains heat, they become hotter, and when they lose heat, they become colder. So all the things, all of these are all the things that you should already know. If you don't, replay this video up to this point so that you know all these heat facts before we go on to uh, answering the question. Okay, it's very important that you must know all this already. Now, another thing that you also need to know before we answer that question is that water always boils at 100 degrees Celsius. Liquid water can never be more than 100 degrees Celsius. Anything less than 100 degrees Celsius, the water will not be boiling. Okay, so water boils at exactly 100 degrees Celsius. All right. Okay, now that we know all this, we know about heat, we know about temperature, we know about how heat flows, we know the temperature in which water boils. Let's look at the question. Mrs. Yun wanted to cook some potatoes. She noticed that when she put the potatoes into the boiling water, the boiling stopped almost immediately. What happens is there's a pot of boiling water. Water is boiling. That means the water is at what temperature? Correct. The water is at 100 degrees Celsius. Alright. Now this water is at 100 degrees Celsius, but when Mrs. Yun put the cold potato, alright, what do you think happened? The cold potato would be gaining heat or losing heat. Correct. Alright. The cold potato will become hotter. That means it will gain heat. Now, if the hot potatoes are gaining heat, right, where is it gaining the heat from? It is put into boiling water. Therefore, the colder potatoes will be gaining heat from the hotter water. Remember, heat travels from an area of hotter region to an area of colder region. So this heat from the water will flow into the cold potatoes until the potato becomes as hot as the water. Now, so when Mrs. Yin put the potatoes into the boiling water, what would happen is that the potato would be gaining heat from the boiling water. That means the boiling water will be losing heat to the potatoes. So as the boiling water loses heat, it was before they put in the potato, the water was at 100 degrees Celsius, but once it lost heat, the temperature of the water actually went below 100 degrees Celsius. When once it goes below 100 degrees Celsius, the water could no longer boil. Right? So that's what's happened. That's what happens when you put colder potatoes into a pot of boiling water. The water will lose heat to the potatoes because the heat will be transferred from the water, boiling water, into the potato. Now, why did the water stop boiling when the potatoes are put into it? Let's look at option one. The boiling water lost heat to the potatoes. That's what we said. The potatoes transferred its coldness to the water. Now, we know in English the opposite of hot is cold, but in science, what the word cold means is that it is, not so very scientific because cold is quite relative. What is cold to us might not be that cold to the polar bears, and so on and so forth. So, actually, the word coldness is just not so used in PSLE science. So the potatoes does not transfer its coldness. In fact, it's the other way around. The hot water transferred its heat energy to the cold water. Okay. Let's look at option three. The heat was lost to the increased amount of water. As you can see, the water here increased, and that is true. But that's got nothing to do with the heat. Okay. The water increased. The water level increased, not because the water amount of water increased. It's because remember we did just now. The water has a fixed volume. It is a liquid. Remember the twisted matter. And the potatoes are solids, and it also has a fixed volume. So fixed volume add to fixed volume, you have a greater amount of volume. Okay, because water cannot be compressed, neither can solid. All right, but the increase in the water level is the same, but the amount of water in the pot remains the same. All right, it has not changed. So the heat was not lost to the increased amount of water. The amount of water did not increase. Option 4, the potatoes prevented heat from traveling to the water. The potatoes prevented the heat from traveling into the water. So option 4 is trying to say that the heat here is trying to get to the water, but the potato stopped it. Well, uh, it looks convincing, but actually, the reason why the water is not boiling anymore is because there is a temperature drop, and the temperature drop is caused by the water absorbing the heat. Sorry, the potatoes absorbing the heat from the boiling water. All right. So if you after that explanation, look through the options. You know, uh, make your choice. But if you didn't understand any part of heat just now, this is a good opportunity for you to revise. Look through the video again. You can replay the video again and again and again until you understand. All right, because uh, heat is definitely going to be tested in your PSLE, in your tests, in your upcoming exam. It might not be in this question, but the concepts that we have covered in this video is very important. So please understand why this question is as such, and what the necessary concepts that you need to know before you are able to answer any question on heat. Thank you.